Welcome friends. In this video lecture we will discuss about groups, which is an important chapter of abstract algebra. Now we are starting. The chapter is groups. To know about the groups, we have to understand the concept of binary composition. Okay, let us take two non-empty sets, capital A and capital B. Then obviously A cross B is nothing but the collection of all ordered pairs, like ordered pair A comma B, where first component belongs to the first set and second component belong to the second set. Okay, now we take a mapping which is F colon A cross A arrow A. That means this mapping associates to each ordered pair A comma B belongs to A cross A, okay, to a definite element C in capital A. Okay, here we denote this mapping by a specific symbol, which is often called compose or operation. Okay, this is called a binary composition or binary operation. Okay, I hope the concept is now clear, and if we represent it diagrammatically, then here we are taking the non-empty set capital A, and with capital A we are taking cross product of capital A, and here we are taking an element small a, here we are taking an element small b, and the ordered pair A comma B is mapped into the element C, which is also an element of capital A. Okay, the usual operations like plus, dot, minus, all are binary operations on certain sets, Okay, recall the fact that if we are taking the set Z, that is set of all integers, then observe the fact that 5 belongs to Z, 3 belongs to Z, 5 plus 3 equals to 8, which is also an element of Z. That means here plus, that is addition, is a binary operation, Likewise, the operation minus, that is subtraction, is also a binary operation on Z. It will be very clear from this example. 5 belongs to Z, 3 belongs to Z. Look at this fact that 5 minus 3, that is 2, belongs to Z. Okay, So I hope the definition of binary operation is very clear. And after that we are introducing some algebraic properties. Okay, algebraic properties which will be applied with these binary operations. Number one is commutative property. Number two is associative property. Okay, and the third part is distributive property. Distributive property. Okay, and there are many more properties like cancellation property. Okay, now I am discussing about commutativity. Suppose compose colon A cross A arrow A is a binary operation on capital A. Okay, and if compose, in fact A compose B equals to B compose A for all A comma B belongs to A, then compose is commutative. Okay, if A compose B compose C equals to A compose B compose C for all A comma B comma C belongs to capital A, then compose is associative. If we take two binary operations compose and asterisk, that is star, on capital A, then if A compose B star C equals to A compose B star A compose C, then we can say that compose is distributive over the operation star. Okay, another important property is cancellation property. Okay, cancellation property means if A compose B as C compose B, which implies A equals to C, then we say that left cancellation property holds. Okay, rather it will be right cancellation property because we are cancelling from the right. Okay, similarly if A compose B equals to A compose C implies B equals to C, then right cancellation property holds. Now look at this fact. This condition is true for all the elements like A, B, C from the set. That means we can say that for all A comma B comma C belongs to capital A, then we can say that the cancellation property holds. Okay, these are the algebraic properties which will be vastly used in group theory. Okay, now we will introduce another important concept, which is identity. Identity element. In any group, identity element is a specific element, that is, it is unique which upon operation with any element gives that element. Okay, that means A compose E equals to E compose A equals to A for all A belongs to capital A. This is identity element. That means small e is here identity element. Okay. And what is inverse of an element? What is inverse of an element? It is analogical with inverse in matrix. That is A inverse for matrix. We know that A inverse equals to In. That is identity matrix. Likewise, here in group also, if A compose A dashed equals to A dashed compose A equals to E, then we can say that A dashed is right as well as left. That is, we can generally or simply say that both sided inverse of A. Okay, this is the concept of inverse element. Okay, and after that we are discussing the final and important definition, that is what is group. Let capital G be a non-empty set and compose is a binary operation defined on it, then if A belongs to G, B belongs to G implies A compose B belongs to G. Okay, this is called closure property. Second condition is A belongs to G, B belongs to G, C belongs to G implies A compose B compose C equals to A compose B compose C. That is associativity. Here we have to write for all. Here we can say that for all A belongs to G, B belongs to G. Here also for all A belongs to G, B belongs to G. And G3, for all A belongs to G, there exists an element E in capital G such that A compose E equals to E compose A equals to A, which is called existence of identity. And G4 is for all A belongs to capital G, there exists an element A inverse in capital G such that A compose A inverse equals to A inverse compose A equals to E. It is called existence of inverse. Okay, then first bracket G comma compose is called a group. Okay, this is the definition of group. And always remember, if in a group commutative property holds, then that group is called an abelian group. Okay, an abelian group. So friends, I hope you enjoyed this session, and very soon we will meet with another video lecture of group theory.